Hello GATE aspirants, welcome to part 10 of GATE Classical Mechanics series. Question number 10. Consider a transformation from one set of generalized coordinate and momentum to another set denoted by these equations where S and R are constants. The transformation is canonical if. Now Q and P is given. For canonical transformation, dou Q by dou Q, dou P by dou P minus dou Q by dou P, dou P by dou Q. This should be equal to 1. That's the condition. So let's calculate it. So dou Q by dou Q is S P Q raised to S minus 1. Then dou P by dou P is 0 minus this will be Q raised to S. Dou P by dou Q is R into Q raised to R minus 1, and that should be equal to 1. That means minus R Q raised to S plus R minus 1. This should be equal to 1. That means R is equal to minus 1. There is no Q term here. That means S plus R minus 1 is equal to 0. But R is minus 1. So S minus 1 minus 1. This should be equal to 0. That means S is equal to 2. So S is 2 and R is minus 1. So option B is correct. Next question. The Hamiltonian for a particle of mass m is h is equal to p square by twice m plus k qt, where q and p are the generalized coordinate and momentum respectively. T is time and k is a constant. For the initial condition, q is equal to 0, p is equal to 0, at t is equal to 0, q of t is proportional to t raised to alpha, the value of alpha is. Let's calculate q dot and p dot. So q dot is equal to dou h by dou p, and that will be equal to 2p by 2m, so p by m. And p dot is equal to minus dou h by dou q, which is equal to minus kt. So from this p dot we can calculate p. So p will be integration of minus kt, so that will be equal to minus kt square by 2 and plus some integration constant. Now at t is equal to 0, it is given that p is equal to 0. That means this c will be 0. So p is equal to minus kt square by 2, that is p. Now q dot is equal to p by m. That means it is 1 by m into p, which is minus kt square by 2. So q is equal to integration of this. So that means it will be minus k by twice m. Integration of t square is t cube by 3 and plus some constant of integration. Now q is equal to 0 at t is equal to 0. That means this c dash should be 0. So q is equal to minus k by 6m into t cube. So q is proportional to t cube. So alpha is equal to 3. Answer is 3. Answer given in the answer key is 3, 2, 3. Next question. A ball bouncing off a rigid floor is described by the potential energy function V of x is equal to mgx for x greater than 0 and infinity otherwise. Now total energy E is equal to p square by twice m plus mgx. So from here, in that region only, and for this case p square is equal to twice m E minus mgx. So it is dependent on x but with minus sign, so it will be parabola like this. So option B is correct. And you can check these boundary conditions as well. If you put p is equal to 0, you will get value of x to be E by mg, and if you put x is equal to 0, you will get value of p to be plus minus under root twice me, and it will be parabola because it is x versus p square graph. So option B is correct. Next question. Consider the Hamiltonian H where alpha and beta are constants, parameters with appropriate dimensions, and q and p are generalized coordinate and momentum respectively. The corresponding Lagrangian is. Now here H is given. From there you can calculate q dot. Now q dot is equal to dou H by dou P. And we have P here. So this will be alpha, then this will be 2P by 2. So P into q raised to 4, that is q dot. From here, P is equal to Q dot upon alpha Q raised to 4. That is P. Now Lagrangian L is equal to PQ dot minus H. Now P is equal to Q dot upon alpha Q raised to 4 into Q dot minus H. H is alpha Q raised to 4 upon 2. Now we have to substitute P here. Now P is Q dot, P square is there, so it will be Q dot square upon alpha square, then Q raised to 8, then minus of beta by Q square. This is L. So now L is equal to Q dot square upon alpha Q raised to 4. Here we have minus Q dot square, and this will be, alpha will cancel out and Q raised to 4. So upon 2 alpha Q raised to 4 minus beta Q square. So L is equal to 1 minus half is half. So Q dot square upon 2 alpha Q raised to 4 minus beta upon Q square. So here option A is correct. 1 upon 2 alpha Q dot square upon Q raised to 4 minus beta upon Q square. Next question. A projectile of mass 1 kg is launched at an angle of 30 degrees from the horizontal direction at t is equal to 0 and takes time t before hitting the ground. If its initial speed is 10 meter per second, the value of the action integral for the entire flight in the units of kg meter square per second is. To calculate action integral, we require Lagrangian of the system. So first step is to write Lagrangian of the system. For that we will require kinetic energy and potential energy, and for that we require velocities and position of the particles. So let's calculate that. Now Lagrangian is equal to half m x dot square plus y dot square minus mgy. Now x dot is equal to horizontal velocity. So this is projectile motion and particle is projected in this direction. Let its initial velocity be u. This angle is theta and this will be u cos theta. There is no force in horizontal direction, so at each point velocity will be u cos theta only. Only the vertical component will change. So x dot is equal to initial velocity u into cos theta, which is 10 into cos 30, which is root 3 by 2, and that will give us 5 root 3. Now y dot is equal to, it will be u sin theta, because this component is u sin theta and there is acceleration in the downward direction, so minus gt. So v is equal to u plus at, that formula I am using. So this will be equal to 10 into half sin 30 minus g will be 10. Here in this question it is given. So g is 10 and t. So this will be equal to 5 minus 10t. So we have x dot and y dot with us. Now we also require y. Now we will use formula s is equal to ut plus half at square. So in vertical direction we have u, which is u sin theta, into t. Acceleration in downward direction, so half. So here we will have minus g into t square. Now this is u sin theta is 5. So this is 5t minus g is 10 by 2, that is 5t square. So these are the values of x dot, y dot and y. Now L is equal to half m. Now x dot is this. Its square will be 5 root 3 square, which is, let me write it first, 5 root 3 square plus 5 minus 10t square minus mg into y, which is 5t minus 5t square. So this is the Lagrangian. You have to solve it. So L is equal to half m. 5 root 3 square is 75. Then square of this, it will be plus 25 plus 100 t square minus 100 t minus, again mass is also given, mass is 1. So this is 1, then mass is 1, g is 10, and we have here 5t minus 5t square. So L is equal to, this is 100 by 2 which is 50, 100 t square by 2 is plus 50 square minus 100 t by 2 minus 50 t, and minus, this is 10 into 5 minus 50 t and plus 5t square. So this is equal to 50 t square, sorry. So this will be equal to, finally L is equal to 100 t square minus 100 t plus 50. Now action integral is equal to from 0 to t. Okay, so we want to find out when it is hitting the ground. For that we require time of flight, and time of flight is 2u sin theta by g, which is equal to 2 into 10 into half upon 10, which is 1 second. So integration is up to 1. 10 100 t square minus 100 t plus 50 dt. So S is equal to 100 t square by 3, but t is 1. So this will be 1 by 3 minus 100 t square by 2. So 1 by 2. I am integrating and putting the limits, plus 50 t1. So 100 by 3 minus 50 plus 50. So S is equal to 100 by 3, which is 33.3 up to 1 decimal place. So answer is 33.3, and answer given in the answer key is 33.2 to 33.4. Next question. Two spaceships A and B, each of the same length L, are moving in the same direction with speeds 4c by 5 and 3c by 5, where c is the speed of light. As measured by B, the time taken by A to completely overtake B in units of L by C. So to overtake it, that spaceship has to cover distance of that other, like length of that other spaceship. Let's first calculate relative velocity. So relative velocity of A with respect to B is equal to UA minus UB 1 minus UA UB upon C square, and these values are given. So this is 4c by 5 minus 3c by 5 upon 1 minus 4 by 5 3 by 5. So this is c by 5, 1 minus 12 by 25. So this is c by 5 and 13 by 25. So this is equal to 13 by, so this will be 5 and 5 will cancel. So we have 5c by 30. So this is the relative velocity. Now with this velocity, the spaceship has to cover its contracted length and also its own length. So contracted length of the second spaceship and its own proper length. That means this v into t is equal to this L in bracket 1 minus v square by c square and plus its own length L. So v is equal to 5c by 13 into t. We want to find out this t. Then we have L here, then 1 minus v square by c square. This is v. So v square by c square is 25 by 169 plus L. So this gives us 5ct by 13, then 1 minus 169 minus 25 is 12 by 13. This will give us 12 by 13. So this means L into 12 by 13 plus L, which is 25 L by 13. So this 13 will cancel. So you'll get 5ct is equal to 25 L. So t is equal to 5 into L by c. So this part is alpha. So this is the answer. So answer is 5. And answer given in the answer key is 5 to Next question. Two events, one on the earth and other one on the sun, occur simultaneously in the earth's frame. So delta t dash is equal to 0. The time difference between the two events as seen by an observer in the spaceship moving with velocity 0.5 c in the Earth's frame along the line joining the Earth to the Sun is delta t, where c is the speed of light. Given the light travels from Sun to the Earth in 8.3 minutes in the Earth's frame, the value of delta t in minutes is. Take Earth's frame to be inertial and neglect the relative motion between the Earth and the Sun. Now, delta t is equal to t2 minus t1, which is equal to t2 dash plus vx2 dash by c square upon 1 minus v square by c square minus t1 dash plus vx1 dash by c square upon 1 minus v square by c square. Now this part is gamma, so gamma into delta t dash plus v by c square delta x dash. So that will give us delta t. Here delta x dash is equal to time taken is 8.3 minutes. So delta x dash is 8.3 minute into c, because light travels with speed c. So let's substitute these values. So you'll get delta t is equal to gamma, which is 1 upon under root 1 minus v square by c square, but that is 0.5 square. Then delta t dash is 0 plus v is 0.5 c by c square and delta x dash is 8.3 into c. So this is equal to 1 minus 0.25 is 0.75 and this is equal to c square, c will cancel, so 0.5 into 8.3 and this is equal to 4.79 minute. Up to 2 decimal places, so answer is 4.79. Answer given in the answer key is 4.77 to 4.81. So these were all the questions from classical mechanics part in GATE 2019 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.